In the latter half of 1618, 3 comets appeared in the skies of the world, one in August and 2 in November, with the final comet being particularly bright. According to Jesuit mathematician and astronomer Orazio Grassi, it was, quote, of such brightness that all eyes and minds were immediately turned toward it. Suddenly, men had no greater concern than that of observing the sky. Great throngs gathered on mountains and other very high places, with no thought of sleep, and no fear of the cold. That stellar body with its menacing rays was considered a monstrous thing. One person who did not observe these monstrous things was Galileo Galilei, whom illness had, as it often did, confined to bed. Of course, comets are hardly shy things, and all Galileo had to do to see one was to step outside. Some have speculated that, as Galileo was perfectly able to conduct disputes and conversations from his bed, his refusal to view the comets likely had more to do with his recent censure by his church, and his reluctance to approach the edge of his rhetorical cell. Galileo was not a superstitious man, so I doubt he fell in with the age-old vision of the comet as a harbinger of doom. But I do wonder if, decades later and with the benefit of hindsight, he pondered the possibility. The following year, Grassi published Of the 3 Comets of the year 1618, in which he drew upon the work of Tycho Brahe, arguably the greatest observational astronomer of his age, who, in 1577, had shown that a visiting comet displayed no diurnal parallax. That is, it did not change its apparent position relative to the position of the observer on the Earth. Since the Moon did, any object that did not must be further than the Moon, and thus beyond the earthly sphere. Aristotle had argued that comets were merely fiery exhalations from the Earth, igniting in our atmosphere. But Tycho had shown that Aristotle had to be wrong. Galileo had spent much of his life arguing against Aristotle, or, more accurately, arguing against philosophers, mostly in universities, who regurgitated Aristotle as if he were Holy Writ, rather than testing his ideas themselves. Grassi had assumed that Galileo would be happy with his work. Indeed, he even surreptitiously praised him. Quote, thus only comets remain aloof in the lynx's eyes. A reference to the Lincaean Academy, the forward-thinking scientific institution of which Galileo was a member. He could not have been more wrong. Galileo, who had spent his working life promoting experience and experiment over exegesis, bizarrely accused Grassi of quoting scientific scripture by citing Tycho's meticulous observations. The lifelong opponent of Aristotle suddenly appeared to endorse Aristotle's vision of the universe. Like Aristotle, he claimed that comets were nothing more than apparitions in our atmosphere, though, unlike Aristotle, he argued that they were not even physical objects, but optical illusions, and have, quote, no other origin than that a part of the vapor-laden air surrounding the Earth is for some reason unusually rarefied, and is struck by the sun and made to reflect its splendor. If a comet were merely a phantom of light refraction, like a parhelion or a rainbow, then it would appear to be in the same position relative to every observer, and so would not show parallax. More forgivably, Galileo argued that comets could not be wandering stars because they appeared suddenly in the sky, rather than, as planets did, slowly brightening and dimming as they advanced or retreated, a mistake likely the result of primitive telescopes. Unforgivably, and indeed inexplicably, Galileo argued against comets because to accept them as independently orbiting objects would entail a solar system so vast as to be incomprehensible. Because comets appear to travel in a straight line across the entire sky, for their orbits to be elliptical, the sky, or the universe as Galileo called it, would have to be less than 1 degree of their entire orbits. Quote, how many worlds and how many universes would have to be assigned to give it space enough for an entire revolution when 1/400th part of its orbit exceeds half of our universe? This multiplicity of spheres I cannot reconcile with the extreme neatness which nature maintains in all her other works by retaining nothing which is superfluous or idle. Coming from an Aristotelian or a theologian of the time, this argument would be unexceptional. Coming from Galileo, it was insane. Galileo had for decades by this point endorsed the Copernican doctrine of heliocentrism, that the sun stood motionless at the center of the universe, and that the earth orbited it, as contrasted with the ancient system of Aristotle and Claudius Ptolemy, in which the earth was at the center and orbited by the sun. One of the oldest arguments against heliocentrism was that were it the case, the stars would display parallax as we viewed them first from one side of the sun and then the other. The fact that they do not would mean, if heliocentrism were true, that the Earth's orbit, and indeed the orbits of all the planets, which are comprehensible and finite, must be as a point to the heavens, and that the outer sphere of the fixed stars must lie beyond a cavity so vast that compared to it, our world and all of its contents would be reduced to nothing. The heliocentric universe Galileo defended would be far vaster than the one he warned Grassi about. And of course it is. Comets can have orbital distances 10 times the diameter of our solar system, while the nearest stars lie at distances 10,000 times farther than that. Indeed, the elusive stellar parallaxes are so minute that they would not be seen for 200 years, long after heliocentrism had already been accepted. But why? Why would Galileo ignore or contradict so many of his most cherished ideas just to keep comets out of the heavens? I have no solid answers, and indeed, why is a question I will be asking again in this video. One explanation for Galileo's apparent lunacy concerns Tycho Brahe himself. Tycho was the single greatest observational astronomer of the pre-telescopic age. His observations, aided by state-of-the-art instruments, led to the most precise positions for the stars ever recorded, positions which his protege, Johannes Kepler, would, after decades of work, convert into the standard astronomical almanac of his time, still in use over a century later. He employed diurnal parallax not only to show that comets were beyond the moon, but also a nova, a term he coined, breaking forever the Aristotelian vision of a changeless heaven. Galileo appears to have had no issue with the parallax measurements for novae. Indeed, when another nova occurred in 1604, he employed that exact method as a challenge to Aristotelians. To dismiss it for comets, Galileo claimed, quote, "Observations made by Tycho and many other reputable astronomers upon the comet's parallax vary among themselves. If complete faith be placed in them, one must conclude that the comet was simultaneously below the sun and above it. But lumping Tycho with the other observers cheapens the value of his observations. As Kepler, who was a colleague of Galileo, put it, Galileo, if anyone, is a skilled contributor of geometrical demonstrations, and he knows what a difference there is between the incredible observational diligence of Tycho and the indolence common to many others in this most difficult of all activities. Therefore it is incredible that he would criticize as false the observations of all mathematicians in such a way that even those of Tycho would be included." Galileo's need to discredit Tycho stemmed not from any personal animus. The man had been dead for nearly 20 years, and Galileo had neither met nor corresponded with him, but from the threat posed by Tycho's vision of the universe. Like Galileo, Tycho had concluded that the Ptolemaic system was flawed and incomplete. But the master of parallactic precision refused to accept the Copernican system without parallax to back it up. And so he developed a compromise, the Tychonic system, in which the Earth remained motionless at the center of the universe, with the sun, moon, and stars in orbit around it, while the 5 planets, Mercury, Venus, Mars, Jupiter, and Saturn, orbited the sun. The Tychonic system accounted for all the observed celestial motions as well as either Ptolemy or Copernicus, and, crucially, Galileo's numerous discoveries, such as the moons of Jupiter and the phases of Venus, while certainly putting paid to Ptolemy, could not disprove Tycho. Until rock-solid proof could be found, if the Tychonic system stood as an alternative, the Copernican system would never be entirely accepted. If Galileo could not disprove Tycho, he had to discredit him, and so he resorted to every trick in the book, layering scorn and vitriol against his perceived detractors. The comets were, quote, Tycho's monkey planets, and Tycho's ideas were elephantine, while Grassi was a buffoon, evil poltroon, and an ungrateful villain. His final word on the subject, a hulking tome called Il Saggiatore, usually translated as The Assayer. The title is meaningless and comprises one side of a mudslinging contest between Galileo and Grassi, targeted not just Grassi but Christoph Scheiner, with whom he had crossed swords over sunspots years earlier. The Assayer contained many references to sunspots, which Scheiner believed Galileo had stolen from him. Since they were both observing at the same time, it is possible the similarities were coincidental, but it nonetheless led to years of bad blood between the two. Both Grassi and Scheiner were Jesuits, the same order that, in 1611, had hailed Galileo like a king for his achievements, and they, justifiably, felt that Galileo had betrayed them. Galileo, in turn, felt that they had betrayed him first, by not supporting him during his trial in 1616, and his commentary work was littered with jibes at their expense. The fact that they overwhelmingly embraced the Tychonic system could not have helped. In a courtier's world of building bridges, Galileo was more content to burn them. But perhaps Galileo's deepest revulsion at the idea of comets as celestial objects was that their orbits, if they existed, had to be vastly distended ellipses. For all his rejection of Aristotle, Galileo shared one overriding obsession with him, a need for all motions to be circular. Galileo was the first to move away from Aristotle's theory of rest and motion. To Aristotle, the natural state of a body was at rest, and it only moved when acted upon by an outside force. Galileo, conversely, realized that, without friction, a body would continue to move in the direction of the applied force until acted on by another force. However, he never could accept this for objects outside of the Earth, because, as the Earth was a sphere, all linear motions on its surface were actually circular. Galileo could not develop a full theory of inertia, what would become Newton's first law, because he could never envision an object moving forever in a straight line. The universe could not be infinite. All linear motion must have an endpoint. Only circular motion was perpetual. This is also very likely the reason Galileo never adopted Kepler's laws of motion, as they showed planetary orbits as less than perfect circles. In 1623, the Vatican censors allowed the Assayer to be published, and it was a smash hit. Considered to this day a masterpiece of polemic, which is why it is seldom read out of its native Italian, it was hurriedly dedicated to the only just appointed Pope Urban VIII, previously known as Galileo's old friend, Cardinal Barberini. It was only fair. 3 years previously, Barberini had composed a poem in Galileo's honor, called Pernicious Flattery. When the moon shines forth in heaven, and sprinkles the glittering fires in a serene arc, in a golden procession, then marvelous delight draws and holds fast the eyes of people. This person here marvels at the heart of the scorpion, or at the blazing dog star, or at the attendants of Jupiter, or of Saturn his father, that were discovered by your glass, learned Galileo. A sweet ode indeed, except of course that moonlit nights are among the worst times to do astronomy. In 1624, Galileo returned to Rome, and was showered with gifts from the grateful new pope, including a precious painting, a gold and silver medal, and a pension for his son Vincenzo. In 6 long audiences with Galileo, Urban assured him that he was free to discuss the Copernican theory, but only as a purely mathematical hypothesis, because, quote, man cannot presume to know how the world really is, since God could have brought about the same effects in ways unimagined by humans. It is not proper to restrict God's omnipotence. It was an admonition that Galileo would one day rue. Everything was looking up for Galileo. His patronage, thanks to the Grand Duchess Christina, was secure, and with his son's pension, the Pope had ensured his legacy was too. Cardinal Bellarmine, who had led the Church's censuring of Galileo for his Copernicanism, was dead, and Pope Urban, Galileo's friend, had seemingly given him a green light to discuss Copernicanism again. A man in Galileo's position might decide to proceed cautiously, careful not to press his luck. Galileo Galilei was not that man. and, believing his shackles unbound, began the work that would, in due course, destroy his life. The first draft of the work comprised a letter to Francesco Ingoli, who in 1616, in his capacity as head of the Vatican's missionary arm, had sent Galileo a letter rejecting Copernicanism. Emboldened by his friend's ascension to the Holy Seat, Galileo at last was primed to respond. The letter is proof, if any were needed, that Galileo had no medium setting. After dispensing with the required pleasantries, it rapidly descends into his trademark acid mockery. Quote, "For Mr. Ingoli, if your philosophical sincerity and my old regard for you would allow me to say so, you should in all honesty have known that Nicholas Copernicus had spent years on those very difficult studies that you had spent days on. So you should have been more careful and not let yourself be lightly persuaded that you could knock down such a man, especially with the sort of weapons you use, which are among the most common and trite objections advanced on the subject." To be fair, if Galileo is right, some of Ingoli's arguments were true howlers, such as claiming that parallax increases with distance instead of decreasing. In the letter, Galileo once again embraced the vision of a vast, empty universe he so roundly rejected in his battle with Grassi. Quote, "So that I do not seem to evade the strength of your point, let us assume it is true that the annual orbit appears imperceptible relative to the stellar sphere, and that to appear such, according to Tycho, requires the fixed stars to be 15,406,000 terrestrial radii away. What impossibility or inconvenience do you find in that, Mr. Ingoli? It seems to be that all impropriety lies in man's imagination, and not at all in nature itself." Incidentally, 15.4 million Earth radii is about 593 AU, or 1/450th the distance to the nearest star. One wonders if Galileo could have imagined that. Aside from laying the ground for Galileo's coming work, the letter to Ingoli was also notable for containing Galileo's last substantive scientific contribution, the theory of relativity. No, really. What we think of as the theory of relativity today is Einstein's, admittedly fairly substantial, rework of Galileo's and later Newton's earlier draft, in which, to counter the arguments against heliocentrism, he dispensed with the idea of absolute rest. In Aristotle's and Ptolemy's universe, if someone dropped a ball, everyone on Earth could agree precisely where it landed. If someone threw a ball from a moving platform, the ball would land at the point at which it was initially dropped. And so it was argued, the Earth could not be in motion, as any objects dropped from a height would land at an angle from their starting point. But Galileo, through a simple thought experiment, showed that all motion was, ultimately, well, relative. Quote, "Shut yourself up with some friend in the main cabin below decks on some large ship, and have with you some flies, butterflies, and other small flying animals. Have a large bowl of water with some fish in it, hang up a bottle that empties drop by drop into a wide vessel beneath it. With the ship standing still, observe carefully how the little animals fly with equal speed to all sides of the cabin. The fish swim indifferently in all directions. The drops fall in the vessel beneath. And in throwing something to your friend, you need throw it no more strongly in one direction than another, the distances being equal. Jumping with your feet together, you pass equal spaces in every direction. When you have observed all these things carefully, have the ship proceed with any speed you like, so long as the motion is uniform and not fluctuating this way and that. You will discover not the least change in all the effects named, nor could you tell from any of them whether the ship was moving or standing still." Unquote. Today, a 4-year-old proves Galileo right every time he runs out of control on a plane. From his perspective, he's racing up and down his metal cage, raging against his confines. From the perspective of anyone on the ground, he's moving through the air at 1,000 kilometers an hour. Those seated around him would likely consider themselves at rest, and indeed would likely curse the kid for disturbing said rest. But they are only at rest relative to the plane. The plane, relative to the Earth, is speeding through the sky, while the Earth, relative to the Sun, is speeding 100 times faster, and the Sun, relative to the center of the galaxy, is speeding 8 times faster still. He once demonstrated this on a boat by requesting a heavy key from a friend and then, to said friend's horror, throwing it in the air. The friend, expecting the key to be lost in the river, was shocked to see it land back in Galileo's hand. The letter to Ingoli was never published in Galileo's lifetime, but circulated in manuscript form. Apparently, Galileo saw it as a means to test the limits of the Pope's tolerance. But Urban, distracted by a flaring of the 30 Years' War, likely never read it, which is just as well. Galileo would require another 6 years to complete his work of personal ruin, the dialogue concerning the two chief world systems, Ptolemaic and Copernican. Note the conspicuous absence of the Tychonic system. On some level, Galileo must have considered it a rhetorical triumph. By portraying the Copernican system as the only viable alternative to the Ptolemaic, he could sidestep the increasingly widely accepted Tychonic system, and by framing it as a dialogue, he could hand his support of Copernicanism to a fictional character, with other voices to act as a counterbalance, allowing the reader to reach his own conclusions. You might assume that such a work could only be neutral and objective, and you'd be right, save for one small fact. Galileo could not be neutral or objective if his life depended on it, and very soon it would. The dialogue concerning the two chief world systems is presented as a Platonic-ish discussion between three figures: a Copernican named Salviati, named for a friend of Galileo, a neutral mediator named Sagredo, also named for a friend of Galileo, and Simplicio, a follower of Aristotle and Ptolemy, named for a 6th century Aristotelian commentator. Yeah, sure, Galileo. And the fact that simplice, or simple, was a common term for a moron had nothing to do with it. Even if you think that's a coincidence, I assure you the Roman Curia did not. It only gets worse from there. If you were hoping Galileo's dialogue would be a nuanced, layered examination of the topic of Copernicanism, its words twisted and perverted by Galileo's unscrupulous opponents, well, you hoped in vain. Galileo was many things, but subtle was not one of them. Salviati outright states the superiority of the Copernican model on numerous occasions. Quote, "The ills are in the Ptolemaic," he proclaims, "and the cures are in Copernicus. Those who endorse the opinion of Aristotle and Ptolemy are imbeciles who engage in the sort of follies that are designed to make the common people unwilling to listen to this innovation. Aristotelian ideas are an utterly delusive chimera, and its believers were too stupid to recognize their own limitations." Meanwhile, Sagredo, the neutral moderator, provides such probing responses as, quote, "I have not heard anything more admirable than this, nor can I believe that the human mind has ever penetrated into subtler speculations." And, "Oh, Nicholas Copernicus, what a pleasure it would have been for you to see this part of your system confirmed by so clear an experiment." As for Simplicio, he does little but parrot Aristotle and Ptolemy in response to Salviati's arguments, even arguing that they must have known what Galileo had recently discovered and discarded it as unimportant. In response to new knowledge, he says, quote, "Frankly, I have no interest in reading these books, nor up to now have I put any faith in the newly introduced optical device." Sagredo notes that Simplicio's time with Salviati has, quote, "increased his capacity to reason rigorously. At one point, Simplicio even defends simple people, as it is not their fault for being simple, in case you were wondering if the pun really was accidental." Galileo even gives himself a shout-out. At one point, Salviati argues that their friend, the learned Lincaean, had discovered sunspots, a somewhat ridiculous assertion given that they had been observed for centuries. So if it fails as an impartial treatise on its topic, or even as persuasive rhetoric, does the dialogue actually have evidence to support its argument? Unfortunately, no. Galileo offers three main evidences in favor of Copernicanism: the retrograde motions and varying brightness of the planets, both of which are adequately addressed by the Ptolemaic model, including the phases of Venus, which is adequately accounted for by the Tychonic model, his hypothesis on the tides, which, if you watched my previous video, you'll know was so ridiculous it was disproven even by his contemporaries, and his arguments from sunspots, a proof so convoluted and obscure that authors have for centuries debated as to what it actually was. The most concise summation I have found has it argue that, over the course of the year, the path sunspots take across the sun appears to rock up and down, with it first appearing to arc above the equator, then lie at the equator, then arc below it, before returning to the equator again. This could be explained if the Earth lay at an angle to the sun's equator, and so viewed the sunspots from slightly different angles depending on its position relative to the sun. And in fact, this is true. The Earth is tilted approximately 7.5 degrees from the solar equator, which does indeed create such a phenomenon. However, it is not proof of heliocentrism, as it could be explained geocentrically by adding another motion to the sun. Galileo could only argue that the Copernican solution was simpler, and nature prefers simplicity. That is true as well, but it is hardly the dry, abstract mathematical argument to which Galileo had been ordered to adhere. It is only at the very end of the dialogue, when, forced to acknowledge the constraints under which he wrote, Galileo has Salviati say, quite out of the blue, quote, "I do not claim that assent, which I do not give to this invention, which might very much turn out to be the most foolish hallucination, and that his fascination with Copernicanism lies, quote, partly from the novelty rather than the certainty." As if to put a stamp on this, frankly, feeble disclaimer, Galileo gives the last word to Simplicio. Quote, "If no reasons more agreeable to natural phenomena were presented to me, I should pass on unhesitatingly to the belief that the tide is a supernatural effect, and accordingly miraculous and inscrutable to the human mind, as are so many others which depend directly on the omnipotent hand of God." It is at this point that I, as a hopefully impartial observer from centuries hence, feel a despairing urge to reach back through time, grab Galileo by his lapel, and simply scream, "Why?" If you remember, during their long audiences together, Pope Urban had granted Galileo leave to discuss Copernicanism, provided he never intimate that it represented physical truth. For, quote, "Man cannot presume to know how the world really is, since God could have brought about the same effects in ways unimagined by humans. It is not proper to restrict God's omnipotence." Now, compare that warning which Pope Urban, Galileo's friend, who had written a poem in his honor, gave Galileo in good faith, with the words uttered above by Simplicio, the moron, who in that same passage describes himself as forming, quote, "feeble ideas on the matter." To be strictly fair, Simplicio does say he received this warning from a learned friend, but it carries little weight after 300 pages of dullardry. These days, the human race is hopefully attuned to the dangers of expressing our thoughts in published words for the world to see. Galileo, living at a time when mass communication was still just born, had yet to learn that lesson. But he would. In 1630, Galileo traveled to Rome yet again to submit the dialogue concerning the two chief world systems for approval by the Vatican. Initial signs were encouraging. Niccolò Ricciardi, the Vatican's chief censor, and the consultant assigned to review it, assured him that the dialogue would pass with minor revisions. Then they read it. The censors roared in response to the text and demanded major revisions, but due to an outbreak of plague, communications between Florence and Rome were interrupted, allowing Galileo to have the book examined and printed in Florence, where he happened to be a favorite of the royal family. In February 1632, the dialogue concerning the two chief world systems was published, and immediately sold out. Copies were soon circulating throughout Italy. We don't know if Urban ever read the dialogue, but we do possess a detailed account of his response, thanks to the Tuscan Secretary of State, who at the behest of Galileo's patron, the Grand Duchess Christina, intervened on Galileo's behalf. I think you can imagine what that response was. While we were discussing these delicate matters of the Holy Office, the secretary wrote, His Holiness exploded into a great anger and suddenly told me that even our Galilei had dared entering where he should not have, into the most serious and dangerous subjects which could be stirred up at this time. This time was the 30 Years' War, the catastrophic ideological conflict between Catholics and Protestants that would claim 12 million lives, and which, at the time, Catholicism was losing. In 1631, 2/3 of the Catholic army had died at the Battle of Breitenfeld. This had been partly due to the French, who, despite being Catholic, had supported the Protestant side to further their territorial war with Spain. With France playing both sides, Urban's attempts to hold Catholic Christendom together were failing. The one thing he could not afford to appear was weak. "The Pope believes that the faith is facing many dangers," wrote the Tuscan secretary, "and that we are not dealing with mathematical subjects here, but with Holy Scripture, religion, and faith." Beyond matters of doctrine, beyond geopolitics, beyond even the implied insult, what truly ate at Urban was what he saw as Galileo's betrayal. He had been Galileo's friend, had dined and conversed with him, and had even brought down the charges in his previous conviction. Yet Galileo had conspired to publish the book not only without Urban's approval, but without even telling him. Galileo had personally wounded the most powerful man in the Western world. And now the gloves were off. Quote, "I did not believe His Holiness would bring about the prohibition of an already approved book without at least hearing Mr. Galilei first," wrote the Tuscan secretary. "His Holiness answered that it was the least ill which could be done to him, and that he should take care not to be summoned by the Holy Office, that he has appointed a commission of theologians and other persons versed in the various sciences, serious and of holy mind, who are weighing every minutiae word for word, since one is dealing with the most perverse subject one could ever come across." When further pressed, Urban simply screamed, "Enough! Enough!" Unsurprisingly, the Inquisition found many examples in the dialogue of Galileo openly and unambiguously supporting the Copernican doctrine. Inquisitor Melchior Incofer noted that connecting the heliocentric model to unexplained phenomena such as the tides or geomagnetism constituted teaching, and that the work consistently ridiculed those who held the scripturally aligned vision of the universe as small-minded. He also noted that Galileo's stated rationale for writing the dialogue, cited in the introduction, that foreigners had claimed that Catholics were unaware of the arguments and mathematics behind the heliocentric position, was blatantly false. For one thing, there had been no such claims by any foreigners, and for another, if Galileo truly wished his work to be read by foreigners, why had he written it in Italian? Surely a work for a foreign audience would be written in Latin, the language of international communication. The only reason to write in Italian, said Incofer, was, quote, "to entice the view of the common people in whom errors very easily take root." Another inquisitor, Zaccaria Pascaligo, argued that, although Galileo at the beginning of his book claims to want to deal with the Earth's motion as a hypothesis, in the course of his dialogue he puts the hypothesis aside, using unconditional arguments. Which is a pretty fair reading. In October 1632, Galileo was summoned to Rome for trial. Citing his age, he was 68, and his eternal ill health, Galileo asked if he could be tried in Florence. Urban responded that Galileo, quote, "could come slowly in a litter with all comforts, for indeed it was necessary to examine him personally, and that God would hopefully forgive his error of having gotten involved in an intrigue like this, after His Holiness himself, when he was cardinal, had delivered him from it." After further procrastination, Urban told Galileo that if he didn't come to Rome of his own accord, he would be dragged there in chains. In February 1633, Galileo, having composed his last will and testament, arrived in Rome. As a special favor to the Grand Duke, Urban allowed Galileo to reside at the Tuscan embassy, though he was forbidden social contacts. In April, Galileo was transferred to the vacant apartment of the Grand Inquisitor, which, while certainly a fine dungeon, must have been an eerie experience as he awaited that man's verdict. From the 12th to the 30th of April, the Inquisition pressed Galileo on his work. Galileo's main defense was a letter written for him by his earlier accuser, Cardinal Bellarmine, who had declared that, quote, "the doctrine attributed to Copernicus, that the earth moves around the sun, and that the sun is stationary in the center of the world and does not move from east to west, is contrary to the Holy Scriptures, and therefore cannot be defended or held." Unquote. The Inquisition, conversely, provided a missive that ordered Galileo, quote, not to hold, defend, or teach it in any way whatsoever. Galileo claimed that this phrasing was, quote, new and unheard to him, which has led many scholars to wonder if the decree was doctored, or even simply inserted into the record by Galileo's opponents. However, ultraviolet testing has shown that if the document was fabricated, it was fabricated in 1616, when Galileo's first injunction was handed down. With Bellarmine dead, there was no one to refute or corroborate Galileo's version of events. Even so, the Inquisition had concluded that, teaching or not, the dialogue still constituted a pretty vehement defense of Copernicus. Galileo responded that, quote, I show the contrary opinion, and show that Copernicus's reasons are invalid and inconclusive, which was, if not an outright lie, then wishful thinking. In his second deposition, he somewhat amended his claims, quote, I freely confess that it appeared to me in several places to be written in such a way that a reader, not aware of my intention, would have had reason to form an opinion that the arguments for the false side, which I intended to confute, were so stated as to be capable of convincing because of their strength, rather than being easy to answer. On the 22nd of June, the Inquisition declared Galileo, quote, vehemently suspect of heresy, which, despite the wording, was a form of guilt. The decision was not unanimous. 3 of the 10 inquisitors abstained. As part of a plea deal, Galileo, garbed in the robe of a penitential criminal and kneeling, abjured by his own hand and declared, quote, I, Galileo, son of the late Vincenzo Galilei of Florence, 70 years of age, abandon completely the false opinion that the sun is the center of the world and does not move, and that the earth is not the center of the world and moves. Since the 18th century, a legend has circulated that he then muttered, and yet it moves, under his breath. But given that this would have been suicidal even for Galileo, it almost certainly never happened. To his horror, Galileo was sentenced to life imprisonment at the pleasure of the Inquisition, thankfully later commuted to house arrest, which Galileo elected to serve in Alcetri, to be near his favorite child, Virginia, whom he'd hoped would aid him in his increasing infirmity, as her mother, Marina Gamba, had been dead for over a decade. Unfortunately, Virginia died the following year of dysentery, leaving the aging and incapacitated Galileo bereft. That same year, Galileo suffered a painful hernia, which, due to his house arrest, he was unable to treat, and so suffered agony for what remained of his life. One of the consequences of Galileo's conviction was that not only was the dialogue banned, but he was forbidden from writing another work. But he was Galileo, and so set about writing one anyway. The Discourses on the Two New Sciences was less a work of discovery than a summation of the theoretical discoveries Galileo had made over the previous 30 years of his life, now gathered under the banner of his priority. The two sciences in question were mechanics, the strength of materials, and kinematics, the study of motion, much of which I've mentioned in previous videos. It was thanks to the Dutch firm of Elsevier, to this day one of the premier publishers of scientific journals, that the Discourse was published at all. In the dedication, he related a story in which he had smuggled the text out of Rome during the trial by handing it to the French ambassador. The story is completely false, but it served to anger Urban. Galileo's last gift to the world was the design for a pendulum clock, drawn by his son, on whom he was increasingly dependent, at his dictation. When he finally died in 1642, after 8.5 years of confinement, the church forbade his burial on consecrated ground and demanded his grave remain unmarked. His corpse was instead interred first in a private garden, and then, when at last constructed in 1737, a proper tomb. When his body was unearthed for relocation, another body, a woman's, was found beside him. To this day, her identity remains a mystery. 3 of his fingers and 1 of his spinal vertebrae were taken from his skeleton as secular relics. His middle finger stands, impudent and proud, in a glass case in the Museum of the History of Science in Florence, a legacy of which I believe he would have heartily approved. The true legacy of Galileo Galilei is a topic as heavy as lead. However you view his contributions to science, his impact on Western culture far outshines them, to the point, some argue, of exaggerating his scientific impact at the expense of more transformative figures, such as Johannes Kepler or Tycho Brahe. It says something about Galileo's mythic magnitude that those who wish to tear him down often portray him as much of a conniving wretch as those who praise him portray him as a saintly martyr. Throughout the series, I have attempted to paint as unbiased an image of the man as possible, illustrating his many flaws whilst not downplaying his accomplishments, which were considerable. Was Galileo the father of modern science? No, because science doesn't work that way. Science isn't a land to be conquered by towering Nietzschean Übermenschen. It is a mountain gradually, endlessly chipped away by a million diligent hands. Galileo drew on the work of others before him, just as those after him would draw not only on his work, but on those of his contemporaries, on into the present. Newton was not a humble or self-effacing man, so when he said he stood on the shoulders of giants, he meant it. To imagine science as a dam opened by Galileo after centuries of stagnation is to ignore not only the accomplishments of the Islamic Golden Age, in particular the work of Ibn al-Haytham, whose use of experimentation and observation predates Galileo by 600 years, but even Galileo's experimentalist contemporaries, such as William Gilbert, the discoverer of Earth's magnetic field. While the Galileo myth has damaged understanding of the history of science, the equally mythic reaction to it, which has attempted to wrest from his hands any credit for his accomplishments whatsoever, also ignores how science works. It is true that most of Galileo's discoveries, had he not made them, would have been made by other people, and indeed were. But this is true of any scientific discovery. Great science is not great art, the sole property of the grand genius who constructs it. The world's secrets remain to be unearthed, regardless of who does the unearthing. Newton did not independently invent calculus, and Darwin did not independently formulate evolution. And yes, Galileo was an arrogant, boorish narcissist who often belittled or outright poisoned the accomplishments of others. But was he really any worse than Tycho Brahe, who resolved arguments by throwing the participants into his personal dungeon? Or Isaac Newton, whose personal vendettas against his scientific rivals persisted even after their deaths? The fact is, science is a merciless discipline, and often suits a ruthless character. But no aspect of Galileo's story has been more slathered in myth than his trial by the Inquisition, which I hope I have shown was not simply about a smothering religious authority's desperate attempt to extinguish the spark of independent thought, but a deeply flawed and self-destructive human being's tragic inability to accept or even see the bonds he was snared in. Before he published the dialogue, Galileo was still well regarded by the Church, and even after his conviction, many in the hierarchy still supported him. Galileo had no evidence to support his claim of heliocentrism, nor would any emerge before the confirmation of Newtonian mechanics in the 18th century. It is true that the dialogue was not removed from the Index of Forbidden Books until 1835, 3 years before Friedrich Bessel's observation of stellar parallax rendered the debate moot, and also that following the Galileo affair, Italy would become a scientific backwater, with Northern Europe rising to take the reins. But the Vatican would eventually become a scientific force, producing such luminaries as Father Giuseppe Piazzi, the discoverer of Ceres, and Father Angelo Secchi, the founder of astronomical spectroscopy. Ultimately, what can we say Galileo contributed to the advance of science? Is there anything about which both his acolytes and his detractors can agree? I think the one thing Galileo did that arguably only he could have done lay not in his scientific discoveries, but in his propagation of them. For all his flaws, Galileo was always larger than life, even in his lifetime, and so everything he did, for better or worse, rippled across the ages. Galileo wrote for the masses, not the elite. The Starry Messenger was a pop science book before the age of pop science. While he was not the only scientist of his time, or even before, to advocate for observational and experimental discipline in the scientific method, he was the one everyone listened to. Galileo attracted myths, and myths teach. Even the likely false stories, such as the one about the Tower of Pisa, explain more about universal gravitation than a textbook can. The extent to which Galileo has been mythically reconstructed can be seen in the fact that one of his most oft-quoted musings on the nature of science is taken from the Essayer, one of his least scientific books. Quote, "Philosophy is written in the grand book of the universe, which stands continually open to our gaze. But the book cannot be understood unless one first learns to comprehend the language and to read the alphabet of which it is composed. It is written in the language of mathematics, and its characters are triangles, circles, and other geometric figures, without which it is humanly impossible to understand a single word of it. Without these, one wanders about in a dark labyrinth. It is for these flashes of light, rather than the labyrinth of historical reality, that Galileo should be remembered."